Hello YouTube, De-bodgery here. Welcome to EV Components Review. This is going to be another overview video. There won't be a macro video for this. And again, it'll be all just based on photos because it's the kind of content I can make right now. Um, yep, when all of your equipment gets stolen, then yeah, you're kind of tied to what you can do. Anyway, we can still do a lot with that. So this, despite the silk screening on the shell, is a Spintend 85-250. If you look on their website, yeah, they call this an 85-250. If you have something that's slightly newer than this 85-250, they have fixed that mistake too, and it now says 250 amps on the shell and not silkscreen 200 like this one does. So anyway, minor details. This is an 85-250 in every other way. In fact, silk screening on the board even says something else too. It says 100 volt, 200 amps. So which is it? Is it 85 volts or is it 100 volts? Really, it's all 100 volt parts. What they're expressing here by 85 volts is this is the maximum voltage that we want you to run this at. Um, yeah, later on, after they originally made this controller, they realized they could run it a little bit higher, i.e. 250 amps, which is why you see it now as 85-250 rather than 85-200 like you've got here. Okay. So you're going to hear me compare with FlipSky quite a lot. And FlipSky has come out with their Pro Series controllers. And as far as they're concerned in Spintend, um, there is not a tremendous amount that delineates one from the other. Um, yeah, FlipSky and all their great marketing wizardry, they called meeting the minimum requirements to be VESC a Pro controller. And that's really what they've done because they're so-called pro controllers, they actually have phase filtering built into them, aka current sense amplifiers, built on the board. So they've got those now, which they should have had all along and didn't because well they're really really cheap. And in the Pro Series they have ceramic caps as well. Not a lot, but they do have some. And in their non-pro stuff, well, they're lacking both of those. So really what it is that Spintend and FlipSky Pro are basically on the same playing field of the lowest possible quality that you can get out of VESC and still meet the minimum requirements and be VESC. So yes, you're going to hear me make comparisons like that quite a bit. And Spintend, they're the same chips. They're using GG MOSFETs, and FlipSky uses YE MOSFETs. But otherwise, there's really very little difference between the two. But nevertheless, Spintend is still a skosh better in most ways than is FlipSky with their Pro controllers. So whenever I come across things like that, I'll try to point them out as I do. All right, so um, yeah. So one of the ways that Spintend is better is you do get this value add DC to DC converter on board. So here is the inductor for that. They've cut this nice little hole in the shell, which is just going to let water in more easily. And keep in mind that this isn't going to be waterproof in any way. All these connectors, all these GH 1.25 connectors are not waterproof in any way. So don't use this in some place that's going to be exposed to the weather. You're just going to kill your controller. Or you'll get water in the connectors and then things malfunction or whatever. So put this inside something that is weatherproof because it's not weatherproof in any way. And the same thing is true for anything from FlipSky, and you'll see that with other things too, like say the Trampa 75, whatever, or sorry, 103 or yeah, 75 300 or 100 250s, and a few other things too like that are just completely open. They're not waterproof in any way either. And then you'll find other vest stuff that is, like say the Maker X G300. That's pretty much completely sealed up. And you'll see other people too that do that that are completely enclosed. So anyway, just kind of depends on who's doing the VESC, whether they're watertight or not. And well, this is not. So just keep that in mind that you need to do that. I do like these little tabs down here. So this is just machined aluminum. It's part of the actual shell. So as far as mounting this is concerned, it's real easy. You just need 4 screws and ta-da, you're done. You're mounted. So definitely like that. And there's, 2 down here and you can't really see them, but there's 2 up there. Kind of see them peeking out a little bit. Otherwise, this is a really, really basic shell. It is machined aluminum, but that's it. On the FlipSky Pro stuff, not on the not Pro stuff from FlipSky, you have an enable, and you have that in everything from Spintend. So I'm glad that's here, and I'm glad that's in the Pro stuff from FlipSky. I wish it was on everything because it's really stupid that it's not. Having to unplug your battery to turn off your EV is dumb. Literally, just turn off the controller by unenabling it, disabling it, and you're done. How hard is that to do? And yet, on everything except for the Pro stuff from FlipSky, you don't have an enable. And here, everything from Spintend does because it meets the minimum requirements for VESC. Yeah, and they also use value-added fan and an external 12-volt DC to DC. It's not much amperage there, but hey, there's one here. You don't have that on anything from FlipSky. So yeah, kind of like this in the Spintend. All right. Otherwise, everything else here is pretty much the same across the board between the two. Oh, with one other exception I should mention, and that is that the Pro Series stuff, they have the same cheapy Bluetooth module that they used to sell separately, mounted or actually physically integrated into the logic board. And on the Spintend stuff, you still plug one in. Considering how cheap those Bluetooth those modules are, and considering how I've had two of them from FlipSky die on me, I think I would prefer to have it be pluggable rather than being a part of the logic board. So that when it does take a dump, and it's probably going to, I can just plug in another one and I'm back in business. And that's how it is with the Spintend stuff and with the Pro stuff. It's on the logic board. You cannot replace it. Um, so yeah, when your Bluetooth dies, you're kind of screwed. All right, so bottom of the shell, pretty straightforward stuff. Let me move this a little bit so we can see all four screws. There we go. All right, so these four screws in the corners, they hold the lid on. FlipSky does the same thing. The screws are on the bottom, so if you want to take the lid off, you have to pull the controller up to get at the screws. Um, yeah, I think that's kind of annoying. Why not just put the screws right through the top and thread into the bottom? Yeah, I don't care if the screw heads are exposed. The thing's not waterproof anyway, so why do I care? And that makes taking the lid off much, much easier. This is not a heatsink. This is a heat spreader. I don't know the thickness of this material, and the metal core printed circuit board is right underneath that area. Hopefully that's like 6 millimeters thick right there, but I don't know. Um, anyway, if it's going to be a decent heat spreader, it needs to have some thickness of aluminum there. Like I said, 5 or 6 millimeters of thickness. Hopefully it's not really, really thin. I don't know that as fact one way or the other. But this is not a heatsink. This is a heat spreader, and you're going to want to mount this to a heatsink if you intend on running this controller at anything close to its maximum power. Yeah, this is just not going to radiate all the way all that well. It doesn't have any fins on it. The Pro controllers from FlipSky, at least they do have some kind of fins on the bottom, so they're going to radiate better. Gives you a little bit more airflow capability across it for more radiating. But it's not what I'd call great either. It's just not flat like this. This, you really want to plant this on something, and like trampas are the same way. You really are supposed to plant the bottom of it to a heatsink or some other big metal thing that's going to draw heat away. All right, that's not really a design flaw. It's just how this is done. All right, next picture. So here's inside the shell. Yeah, you can see all these openings. So there's battery plus and battery minus wires. Here's your phase wires. Yeah, all the stuff is open. So yeah, water is easily going to get inside the shell. There's no gasket or anything here, so not waterproof in any way. Yeah, there's your USB port, just open hole. I don't know why these are beveled, so that's just more GH 1.25 connector holes, just like those up there are, and they are not beveled. And this is where the inductor comes through, and that's beveled too. So I don't know why they beveled some of the stuff and not others. It didn't need to bevel any of it, to be honest. So yeah, I saw that was that. That's a little weird. Anyway, not waterproof. Yeah, little inconsistencies in here. Um, I don't see any evidence in here of like little rub marks where like a ceramic cap would be rubbing on the underside of this lid, like you saw on the FlipSky 75200 controller that I did a while back. Clearly and obviously, ceramic caps were touching the underside of the lid, and that's a potential short waiting to happen. And you don't see any evidence of that here. So they've got a little bit of clearance underneath the lid, and well, FlipSky just didn't give a shit. So yeah, this is definitely a bit better than that, and hopefully, for anything that they've done since the 75200 and even on the 75200, FlipSky has fixed that problem too, but I don't know that. Anyway, no evidence of anything like that here. So, good job, Spintend. Or how about less shitty job, Spintend? All right, this is the everything assembled underneath the shell. Um, like the heat shrink on the wires, it's a good thing. Yeah, you can see though it's still got like pinched in a couple places where they just weren't careful about getting the wires inside, and it got clamped between the shell and the lid. Yeah, um, so heat shrink is good in that regard. It keeps them from pinching the actual wires. Yeah, that could have been a little bit better. Anyway, still, it's got heat shrink on them. And that's a good thing because that protects the silicone wires from abrading on the shell and having a shorting situation. All right, so if you look at the Pro Series controllers from FlipSky, they have 6 electrolytic capacitors. They're all down on one end. See that in their pictures? And so we only have 5 here, but you've got 3 here, so there's 3 of them there, and then you've got 2 more over on this end. So here's battery plus, and here's battery minus down there. So you get the majority of them over here where battery comes in, but on the far side of the board, you've got 2 more. So this is actually going to be a cleaner battery bus than the FlipSky stuff will, which has all the capacitors down on one end. Yeah, this is going to be less noisy than that is because you've got filtering at the far end of the battery bus that you don't have in FlipSky's Pro stuff, or they're not Pro stuff. So yeah, this is a slightly better design in that regard. Um, yeah, I'll talk about some other things here in a minute, but next picture or next thing I want to show you is unlike the 85-150, which has just simply got little plastic pads on it that are pressing the logic board down to the power stage, this has actually got 2 screws in it. I'm assuming that there's like a nylon spacer underneath this to hold the logic board up off the power stage. But yeah, it's held down by screws and not just pressed down by the lid. So that's definitely an improvement. And then everything else I've got to comment about this logic board, I will do from the next picture. Go to that. Okay, so here is the logic board. Um, so you've got several ceramic caps on here. These are just cleaning up, high frequency noise and probably a little bit of low frequency stuff for the logic board. These ceramic caps right here, they are also across battery plus and minus, but they are on the other side of the MOSFETs that switch on the main DC to DC converter that provides 12 volts for like an external fan. They aren't doing anything for this logic board as far as cleaning up noise. They're purely there for cleaning up this 12 volts. That's it. So don't look at these extra ceramic caps here and say to yourself, "Oh, wow, they're helping with battery bus noise." They're not. Those are purely dealing with noise from this DC to DC from getting back to the battery bus, and that's about it. On the other side of them, they do have a bunch of other ceramic caps for cleaning up that 12 volts. So that's kind of nice to see. Um, I'll show you the other side of this board in a minute, but yeah, basically everything right here is all that external DC to DC converter. You've got a fan connector right here and an external 12-volt connector right there. You have a single MOSFET and a TVS diode, but you have no fuses here. So this is a little bit different than the 85-150, which had 2 MOSFETs and 2 fuses. So 1 MOSFET, no fuses. So they've cut the corners a little bit on this, right? Made it a little bit cheaper than the 85-150. Otherwise this is the exact same functionality as on the 85-150. Same chip, same inductor, same caps, everything else the same, just one less MOSFET and no fuses. I would definitely have liked to see the fuses for sure. Yeah, definitely would like to see the fuses. MOSFET is just probably on the fan, probably not over here in this 12-volt connector. Yeah, I'd say that leaving this on all the time is probably fine, but you probably want one to turn the fan off. Yeah, from some kind of little push button, and that MOSFET provides that. Okay, what else we got on here? So right there, and right there are your 3 current sense current sense amplifiers. So I'm glad to see those because this does meet the minimum requirements to follow the VEST standard. And only with the FlipSky Pro stuff do they also have current sense amplifiers, so you can have phase filtering turned on, whereas the non-Pro stuff in FlipSky, you have to turn phase filtering off because, well, those don't actually meet VEST standards. They're literally missing parts on the board, i.e. current sense amplifiers, to be able to meet minimum requirements to be fully VESC compliant. Up here is your three gate drivers, so high side and low side. These little chips are like Legos. Yeah, they come from a dozen different Chinese sources, and they're all pin for pin compatible. They all work at the same voltage ranges, the same amperage outs, things like that. Yeah, you just basically buy whichever one and put it on the board because they're all about the same. Really no different between one and the other. Uh, I don't know this about the Pro Series from FlipSky, but Spintend has an inertial motion unit on here, IMU, and I don't know if FlipSky does or not on their Pro stuff. But yeah, this is pretty standard stuff for most things that is VESC that you have an IMU. Here you've got one. Right here is your main DC to DC converter for everything on the board. This one provides 12 volts to the board. And then this is a 5-volt linear regulator for all the 5-volt stuff that's needed on the board. And then over here is a 3.3-volt linear regulator. I wish that this was a bigger 3.3-volt linear regulator, physically the size of this one. If you look at most stuff out there that's VESC, they use this 1117 style linear regulator for 3.3 volts. And instead they get this little itty bitty one. All this powering, of course, is the CPU and maybe the IMU. So, really small one is probably just barely adequate for the job, but that's about it. Okay, I'm going to zoom right in because, well, this is Chinese made and I want to show off some Chinese made stuff. Yeah. So I want to show you this capacitor right here, the ceramic cap. Notice how it's crooked. You can see another ceramic cap up here. Notice how it's crooked. Yeah, this is pretty standard fare for Chinese made stuff. They just don't care, right? And well, Spintend is the same thing. We just don't care. So, meh, who cares if parts are crooked on the board? Yeah, it's good enough, right? It's soldered down. Uh-huh. Yep, it's soldered down. And I'm sure there's other parts on here that are also crooked. Yeah, there's another cap that's crooked. Here's a cap that's crooked. Yeah, good job, Spintend, on doing the absolute minimum. Yep, the parts are soldered down. I will grant you that. They are soldered down. But yeah, did you do a good job making sure everything is really nicely aligned and stuff? No, not really. But keep in mind, folks, this is Spintend. It's just only slightly better than, say, FlipSky. Otherwise, it's still much less than everything else that's VESC out there, pretty much. This right here is your CAN bus chip. Otherwise, I'm not really going to tell you anything else about that's on here. Not really that important. That's a DC to DC converter chip. Here is a MOSFET. That powers up this port. Yeah, a linear regulator, ceramic caps for power filtering, so on and so forth. This is not a macro video. Just do an overview, and that's it. All right. So let's move on to the underside of the board. So these MOSFETs right here, they turn on that DC to DC converter for providing that auxiliary 12 volts. So that's kind of cool. I'm assuming this is the shunt for that as well, for measuring current into that little DC to DC so that it can like shut itself off if it gets overloaded. It certainly can't blow a fuse because it doesn't have any. I don't know what this shunt does. I have no idea. Yeah, your guess is as good as mine. If somebody knows, please put it in the comments. These three connectors right here, these go to the phases, to the low side of the phases. This one here probably is like all battery minus, like maybe, well, no, wait, that can't be. Because this one here, all those pins except for like two of them, all solder down to this RF backplane on here. So those two are probably battery plus, and those two are all and those four are all battery minus. Maybe that one is all battery minus. I think that's probably how this works, something like that. Anyway, like the 85-150, this is a two-layer board. In other words, it has just copper on the top and the bottom, but no inner traces. And as a result, they have to run traces on the surface of the bottom side of the board rather than a continuous copper plane on here, which would be much better for noise rejection than this is. And the only place you would actually bring actual circuit traces out is at connectors or like over here for these MOSFETs and things. Otherwise, you would just have a continuous chunk of copper all the way across here to block noise from the power stage from bleeding into the logic board. And all they would have to do to improve that is make this a 3-layer board so that they could make a single continuous piece of copper sheet all across the bottom. But that would cost a little bit more money, and they don't want to do that. So yeah, it's Spintend, right? Just slightly better than FlipSky, but just slightly, not a lot. Anyway, these connectors right here, I'm just gonna make this up because I don't really know which pins do what. I haven't looked it up, but like these 2 pins right here would be like gate drive. Those 2 pins would be like current sense, and those 2 pins would be for the thermistor. And then up here, this is just all gate drive, all gate drive, all gate drive for the high side MOSFETs, and that would be all low side stuff. Anyway, that's pretty much everything I'm going to show here. Not really much else to see. Yeah, and I've already bitched about how cheap it is multiple times. And FlipSky, oops, went too far. FlipSky is no different. They're going to absolutely cut corners as much as they possibly can. And I believe they do the same thing, just a 2-layer board, not a 3. All right, so here is one of the MOSFETs. On the 85-150 board, I later on confirmed that they are the GG brand of MOSFETs and that they're the SH1001s. Same as this is. Just that you have 6 MOSFETs rather than 12 like this has, because this is 250 amps and that's so-called 150. But yeah, anyway, same MOSFETs on both of them. I think this is a little bit amusing. I'm going to zoom right on in to the solder blob stuck down to the board. And you can see all the flux on here. Yeah, not washed. You can see all the flux on the MOSFET, not washed. Yeah, it's Chinese, right? It's exactly the same build quality as like you get from Komodo. Uh, you know, Lowest possible cost. Yeah, look at all the flux on everything else. Yeah, look at all the flux up in here. On the right around the phase wire. Oops, I did the wrong thing. Move down. Yeah, look at all the flux up in here. Yeah, didn't wash anything. Why would we do that? That would just make too much sense. But hey, it's Chinese made and it's made to the lowest cost possible. And Spintend is just that. So yeah, you can cut corners and not wash anything and leave little solder blobs on stuff. So yeah, let's do. Exactly like Komodo does, and just like FlipSky does. Make things at the lowest possible cost as you can, because that's who we are. We are Chinese companies, and we cut corners anywhere we can. All right. So right here, and let me zoom in on that a little bit more. Up, there we go. So you can see it says T4 on there. That is a TVS diode, pretty darn sure. That is a resistor, and that's a capacitor. So that's a gate drive circuit there. And apparently they have some transient problems, and so they needed to put some protection on the thing so that gate drive noise wouldn't pass up the line or whatever with that TVS diode on there. At least that's probably why they have it there. Anyway, there's the gate pin, and all that stuff connects to right there. You can see the next MOSFET over has that too. So yeah, this is on the high side, and the low side MOSFETs. This is low side right here. That's the low side right there. Got my mouse pointer in the wrong place. All right. I want to show you this real quick before I move on. I'm going to zoom in on that connector and run down. There we go. All right. So you'll notice how this looks kind of warpled and stuff in here. Yeah, these plastics are designed to not melt at the melting point of solder. But as you can see, this one's kind of all warped a little bit. I didn't mention this on the 85-150, but you could see that they showed evidence of melting as well. Yeah, that's melting right there. Yeah, the plastics literally got too hot, and probably the reason why is all of this is lead-free solder on all these parts, and yeah, it just simply requires more heat to warm it up sufficiently to get it to melt and flow, and as a result, the plastics suffer a little bit. And if they would have just used a better quality of solder that wasn't quite so cheap, the solder would have melted at a lower temperature, in which case the plastics wouldn't have melted. But this is pretty common that you run into this kind of stuff out of China. All right, next picture. So here is your power stage from above without the logic board in the way. Let me center it a little bit better. Nope. All right. So 3 electrolytic caps over here, 2 over here. Yeah, definitely like having electrolytic caps over here rather than having them all be localized on one end. It definitely balances out battery noise a lot better because if they were all down here, By the time you got down here, this part would be a lot noisier if these electrolytics weren't down here. And instead, they put them on both ends. So good job on that one, Spintend. That's definitely a slightly better design than you see in a lot of other stuff like this. On a negative note, I don't know if this is copper underneath here or brass or what. It's covered in some kind of a chrome tinning or lead tinning, something like that. So I can't tell what the base metal is. Hopefully it's copper. But as you can see, it's two sections and they've soldered them together. Um, why they couldn't have run a single solid copper or brass or whatever this is bar all the way across here, your guess is as good as mine, but clearly they did not. I mentioned this on the 85 150 that it would be a no cost improvement to take the battery wires and solder them down in the middle of the battery buses. They've already got solder here. Why not solder the wires there too? How hard would that be to do? And that would balance out your battery buses rather than having them soldered down here and add all of that inductance to get all the way down to there. It would balance out those battery buses a little bit, and that would be a no cost improvement. All right, you'll notice that this solder is also rather dull, and you can see it up here in battery plus 2. All this is rather dull versus like this. That tells you a great deal about the grade of the solder, and this stuff is super cheap. That's why it is so dull looking, and this is a better grade of solder than this stuff is. Yeah, this board has been touched by multiple hands. So these battery wires were soldered on probably at the factory that makes the board. And then these were soldered on by somebody else someplace else. You can tell because the solder is different. You can tell because the flux is different. It's placed different and things like that. So more than one person has touched this power stage before this ever got assembled completely. You see that in the looks of the solder, how it's flowed and things like that in several ways. Anyway, let me show you one other detail, and I'm pretty sure that this is disappointing. But yeah, when I first saw this, I saw the shiny here, and I thought, oh look, ceramic caps. But I don't think that's the case. I think that right there is literally the solder pad for the legs from the capacitors, and no ceramic caps in there at all, which is kind of what I was hoping for, but I don't think that's the case. So phooey on that regard. Other thing to show here is right there and there and there is your three thermistors for the three phases for measuring temperature. They're in the wrong place. They should be up here and like right in there and right in there. So, down here by your shunts where the board is much cooler isn't really doing much good. You really need to be up there at the center of the phases, and they're not. So they just kind of stuck them wherever they could stick them and didn't bother putting them in a good place. So good job, Spintend, on just completely blowing it for the temp sensors. You completely put them in the wrong place. Also, you'll notice down here, you've got this large gap between the battery minus bus and the shunts, and that's all the way across. That's just a case of move the copper bar up to meet the bottom of the shunts. That's it. Same thing up here, yet no copper across here, and yet, you've got this big gap. So this is a hot spot. Instead, what they did was drop some solder on it and hope that's good enough. And it's not. It's not. That's a high resistance zone on the board that they shouldn't have. I've harped on this with other people, and here it is on this Spintend. And you have the same thing up here. So you got this gap between the high side MOSFETs and the copper battery plus bus. Just close the gap. That's it. And that problem is solved. That's super easy to fix. And you have it on the phase buses as well. The phase buses get some solder blobbed onto them, and that's about it. And truthfully, you should have a piece of copper on here first, and then solder the wires to the copper. With the 85 150, you only have 6 MOSFETs, not 12. So the phase bus is literally smack between the two MOSFETs. I don't care about that one, but this one here, you actually have a phase bus. So reinforce it properly, and they didn't. So how about do some cleanup, guys? Flux all over the board, really? How about washing it? I complained about this on KO Moto 100 times because they're the same way. Their boards are dirty, just like this is. And so this is sloppy. This is a way to cut cost. Just not do something because we just don't give a shit. And here it is, Spintend the same way. Probably if I looked at a far driver or I don't know, Flip Sky or something, I'd say flux all over the board as well. And it's just, we just don't care. So we're not going to care. All right. Uh, yeah. So you'll notice that we've got screws here. Let me zoom back out again, holding the board down. And I believe the 85 150 has screws holding its power stage down to the bottom of the shell as well. There is no screws in the middle, holding the middle down. So yeah, you could have like a big air bubble underneath here, underneath the thermal paste that's keeping the middle of the board up, in which case this could be, a hot spot in there where it's not transferring heat away. If you look at like the Flip Sky stuff, at least it is in the 102, or I'm sorry, the 75 200 I took apart, they had little L brackets with little dinky screws that just simply pin down the corners of the power stage. Very fiddly, not a great design. I would say this is slightly better because at least these are M3 screws, but still, it doesn't hold down the center of the board, and the same thing is true on the Flip Sky stuff. Um, you don't see any squeeze out of thermal paste on the edges or like through these holes or anything like that. So I'm going to hazard a guess that the amount of thermal paste underneath this power stage and the heat spread underneath it is actually pretty minimal. So how well this is planted and thermally transferring to the shell is completely questionable at this point in time. So yeah, I would say probably not all that well. Yeah, probably not all that well. Yeah, I would definitely like to see a little bit of squeeze out of thermal paste through places like around the edges. Of course, Flip Sky went way over the edge with that 75 200 because I mean it had thermal paste just squeezing out of everywhere, and on here you don't see any at all. So definitely needs more thermal paste here, most likely. Don't know how much is under there because I can't see underneath this board. Anyway, at least it's screwed down. That's a good start. Good job, Spin Tab. Or yeah, Spintend. Right here and right there is screws that go through that secure the logic board to the power stage. So it's better than it is on the 85 150, which just has little plastic tabs that the lid presses on. And those are going to help a little bit with securing the power stage, but not much. Still, the whole middle here is not pressed down at all. So yeah, things to improve here, Spintend, for sure. All right. Okay, so there is the only ceramic caps on the power stage right there. And they're up here on this capacitor board and not down here next to the MOSFETs. They really should be down here somewhere, and they really should be between the banks of MOSFETs and on both ends. And so these are there. They're doing better than nothing, but not a lot. Yeah. And I've seen a Flip Sky Pro controller, and it's the same way. It's got 3 ceramic caps on it, all down on one end, not doing much good. Yeah, they're kind of helping just ever so slightly. They are a token quantity of ceramic caps, and that's really all they are. All right, you'll notice just how dull that solder is. Yeah, that's some really low grade lead free solder, and it doesn't flow all that well. Yeah, if you notice that it is not flowed to the board at all, and you can see that on battery plus 2, yeah, there's literally no flow from here to the board. So how much electrical connection between here and here there is, or from here to here there is negligible, not a lot. Yeah, Spin 10, you could definitely do a better job on that. Yeah, that's just called attention to detail, making sure that your solder actually flows from all the things it's supposed to flow from to, and actually connects them all together. And well, that's not really doing that. Yeah, you could do a better job on that one, Spin 10, for sure. Yeah, that's not acceptable. That's not, but here it is. And you notice right there it says 100 volt, 200 amp. So is this thing actually 85 volts or 100 volts? Is it really 200 amps or 250 amps? And yet here it is, right? Yeah, well, that's China. What can you expect? All right. What else do I want to show you here? Before I move on, I don't think there's anything else. Just basically the ceramic caps and the piss poor solder work. Yeah, that's pretty much it. All right, folks. I think that's everything that I want to show you about this thing. This is still just a little bit better than the Flip Sky Pro stuff, but just a little tiny bit better, not a whole lot better. And everything else that's Vesk is still lots better than this is, right? Um, so yeah, this is still kind of just slightly better than the absolute bottom of the barrel, aka Flip Sky, but just only slightly better. It could be lots worse than this, or it can only be slightly worse, I guess, a better way of saying it, but it can be lots better for sure. Anyway, I hope that helps you folks out. This is still slightly better than FlipSky in their pro products, which are not pro. They're absolutely basic, fully meeting VESC standards now, but just still the absolute rock bottom minimum we can get away with to be fully VESC compliant. And Spintend is that as well. Yeah, there's a lot of improvements that could be made here, a lot of quality improvements that could be done, attention to details, things like that that aren't here. Yeah, that you'll find in much, much better VESC products for sure. But yeah, if you're asking me which would I buy, this or the Pro product that's of the same specs, oh, I would definitely buy the 85 250 over those FlipSky products because, well, FlipSky is still the absolute dregs. They really are. This is still just a little bit better, and the price difference is negligibly different or negligibly more. So anyway, hope that helps you folks out. Definitely still like Spintend more than I do Flip Sky, but only just a teeny tiny bit more. And that ain't saying a lot. Anyway, take care. Talk to you all later.